I've had a couple of requests to look at a couple of these integrals in the integration by parts section a little bit more explicitly. In particular, I'm going to look at the integral of secant cubed of x in gory detail, and then we'll look at one of the ones involving a product of exponential and trig functions. The thing to keep straight in your mind is you're working towards getting the value of a certain integral. If you can write down a formula that involves the integral that you're looking for and only stuff that you know, like exponentials and trig functions, then it's not a matter of calculus to finish solving the problem, it's just algebra. With all the symbols, it can get very intimidating looking. So let's go through this in detail. Integral secant cubed of x dx. Nothing looks very promising, but I do know how to integrate secant squared. So I'm going to split secant cubed up into secant x multiplied by secant squared of x. I'm going to try integration by parts. I'll let u equal secant of x. The derivative of u is secant x tangent x. So du is secant x tangent x dx. On the other hand, dv is secant squared x dx. dv dx is secant squared x. V must be an antiderivative of secant squared x, so tangent of x will do. And I'm going to write this out using the integration by parts formula. So integral of u dv is uv minus the integral of v du. Writing in the uv and other quantities that we found, the integral of secant cubed is secant of x tangent of x minus the integral of tangent of x times secant of x times tangent of x with respect to x. The integral of secant cubed, the thing that we're looking for, is this quantity, which has no more calculus in it. That's just algebra and trigonometry. The thing that we're looking for is a known quantity minus this integral. I had two factors of tangent of theta. My task is to get some kind of reasonable way of thinking about this integral. If I can do that, then the integral that I'm after is a known quantity plus, or really in this case, minus something that's reasonable to deal with in terms of the thing that I'm looking for. Our background information should include algebra and simple trig identities. And one of the things that we know is that 1 plus tangent squared x is secant squared x. That means that tangent squared of x is secant squared of x minus 1. So in this bit of calculus that remains, I can write this tangent squared as the quantity secant squared of x minus 1 in parentheses. That quantity is going to get multiplied by secant of x, but that by itself doesn't have any calculus in it. As I said, I'm going to write this out in gory detail. The integral of secant cubed is secant x tangent x minus the integral of secant x times tangent squared of x. That's what we had just said previously. There's no calculus in what I'm about to write down. Tangent squared of x is secant squared of x minus 1. So there is no calculus in that. The ordinary rules of algebra apply to things like the distributive law. I've got secant of x multiplied by, really it's tangent squared of x, but I've written it as the quantity secant squared of x minus 1. The ordinary distributive law is still perfectly valid. This number times that number minus this number times that number. Secant of x times secant squared of x is secant cubed of x minus secant of x times 1, secant of x. So what we have figured out is the integral of secant cubed x dx, which is what I'm trying to find, is a known quantity minus this stuff. And this stuff does still have some calculus in it. If you have an integral of the difference of two functions, such as secant cubed x minus secant x, one of the rules of calculus says I can break that up into two integrals separately. Notice that I put brackets around this so that I'm not going to get confused and mess any plus or minus signs up. The thing that I'm looking for, integral secant cubed x dx, is secant x tangent x minus this stuff, minus the integral of secant cubed x dx, minus is plus integral of secant x dx. That step doesn't have any calculus in it, it's just algebra. Now, if you'll notice, the thing that you're looking for, the integral of secant cubed x dx, shows up on the left-hand side of this equation, but it also shows up on the right-hand side of the equation. One thing I need to do is to just do algebra and get all of those pieces on one side or the other. What I'm going to do is I'm going to add the integral of secant cubed x dx to both sides. Over here, I'm taking some number and adding it to itself. So I'll have 2 times integral secant cubed x dx. Over here, when I add the integral of secant cubed x dx, that cancels out the minus integral secant cubed x dx. There's no calculus in that. That's algebra. So 2 times the integral that I'm actually after is secant x tangent x plus the integral of secant x dx. There is one little bit less piece of calculus to do. I need to write down an antiderivative for secant of x, but that's okay. That's on our list of things that we already know. 2 times the integral that I'm after is secant x tangent x plus natural log absolute value secant x plus tangent x. Once I've got it written this way, 2 times the thing that I'm interested in equals a known quantity. I'm basically done. Divide both sides of this by 2. An antiderivative for secant cubed is half of secant x tangent x plus natural log absolute value secant x plus tangent x. That's one antiderivative, and I get all of the rest of them by adding a constant on. I think the reason that some folks find this kind of problem intimidating is it's got several levels going on. You need to know the trig identity connecting tangent and secant. You need to know your algebra really well. You need to know the integrals that we know about. You need to know about integration by parts. So I guess there's at least 4 layers of stuff that you have to do. Part of it, though, is intimidating looking, but really isn't anything. It's just algebra. You got to keep straight in your head what part is calculus and what part is algebra, and then, of course, toss some trig identities into the mix. In a similar spirit, I'm going to at least go most of the way through this integral. When it gets down to the point that it's just algebra, I'm going to point out that it's just algebra, and then it should be easy to finish. We want to look at the integral of e to the 2x cosine 3x with respect to x in considerable detail. I'm going to let the u equal e to the 2x and the dv equals cosine 3x dx. The derivative of u is 2e to the 2x. U is 2e to the 2x dx. dv dx is cosine 3x. V is an antiderivative for that, so I'll have 1/3 sine of 3x. You could check that by differentiating v. This is correct. Then we're going to write down the integration by parts formula. But again, I'm going to be very detailed about this. The integral that I'm after is u times v minus the integral of v du. If you look at the integral that remains, the remaining calculus we have to deal with, there's a factor of 2 running around in it. There's a factor of 1/3. So I can pull a factor of 2/3 out front. What else? There's a factor of e to the 2x, and there's a factor of sine of 3x, and a factor, if you will, of dx. We are done with that step of integration by parts. In our mind, the u and the v that we used to go from the original integral to this, in your mind, erase them from the whiteboard. They're not there anymore. Totally new problem. I have to come to terms with this integral somehow. I have to figure up some reasonable way of dealing with this integral, the integral of e to the 2x sine 3x. If I can figure out some reasonable way of doing that, then the integral that I'm after is going to be this quantity minus 2/3 times whatever I've decided is a reasonable way to deal with this last integral. So forget the other integration by parts. Look only at this. It's a totally new thing. So in the new deal, I'm not even thinking about the rest of it right now. I just want to think about the integral of e to the 2x sine 3x dx. Obviously, I can try integration by parts. Now, in this integral, the u I'm still going to take to be e to the 2x, so du works out to be the same thing it used to be. The dv is not the same. This isn't the same integral that we started with. We've got a new deal. dv is going to be sine of 3x dx. So the derivative of v with respect to x is sine of 3x. For an antiderivative, cosine of 3x more or less does the job, but it's too big. So I'm going to have negative cosine, that is. V is negative 1/3 cosine 3x. If you differentiate that, you'll get negative 1/3 times the negative of the sine times of 3x, that is, times the derivative of 3x, which is 1, and you'll get back your sine of 3x again. The new deal, this one chunk that we're thinking about, this integral of e to the 2x sine 3x dx, using integration by parts, is given by this messy thing. Now, it looks like we're going around in a circle, which we are, but it's a good circle. We are still working only on this new deal integral. We'll hook it back into the original in a while. Integral of e to the 2x sine 3x is u times v minus integral of v du. I'm going to rewrite this. I could take a factor of negative 1/3 out front of this new integral of the new integral. And I could also take out a factor of 2. I could take out a factor of negative 2/3. Minus 2/3 is plus 2/3. So this new deal integral that we're trying to do, the integral of e to the 2x sine 3x dx is a known quantity. There's no more calculus in that, plus 2/3 times the thing that I'm looking for in the original integral. See, this is very reminiscent now of what happened with integral secant cubed. So probably something like that will work out here. So now return to that original integration by parts that we did at the beginning of this problem. We were looking at the integral of e to the 2x cosine 3x dx, which was a known quantity minus 2/3 times this new deal integral that we have just calculated. We've actually figured out an antiderivative for this quantity inside the brackets. So the thing that we're after is a known quantity minus 2/3 times a known quantity plus a multiple of the thing that I'm after. We should think of this as an algebra formula now. All the calculus is done. All it's left to do is to clean the thing up and get a formula for the integral of e to the 2x cosine 3x. I'm going to multiply through here. 2/3 times negative 1/3 is 2/9. Minus that, this first term is going to be plus 2/9 e to the 2x cosine 3x. Then I've got 2/3 times the thing that I'm after. I've got to multiply that by 2/3 and subtract minus 4/9 times the thing that I'm after. And now hopefully everyone will see there is no more calculus to do. There is no more trigonometry. It's pure algebra from now. The thing that I'm after is something that I know minus 4/9 times the thing that I'm after. This ought to be a fairly easy equation to solve. In terms of the algebra, what this amounts to is I'm trying to figure out this quantity that I'm going to call z. And what we know is that z is something that we know plus something that we know minus 4/9 times z. This is a linear equation for the z. Now I can mess with the terms directly, or if I feel like not messing with fractions very much, except at the end, I can multiply through by 9 to get rid of all the fractions. I decided to do that. So I'm going to multiply through on both sides by 9. Z times 9, A times 9, B times 9, minus 4/9 Z times 9 is 4Z. You see, I'm just being lazy so that I don't have to mess with the fractions. So then add a 4z to both sides, and you find out that 13 times z is 9 times something that you know, plus 9 times something else that you know. Z is 9/13 a plus 9/13 b. In our context, the a is the 1/3 e to the 2x sine 3x. The b is 2/9 e to the 2x cosine 3x. And this z is the integral that you were wanting to calculate at the beginning. And then add on a constant of integration and you're done. I said I was going to take you right up to the point where it's just some algebra left to do. So I'll stop it there. Hopefully everybody sees that this is the same pattern that was involved in the integral of secant cubed, except it's more complicated. At any rate, I hope this helps out some. Anytime that you have any questions about anything, feel free to ask. I'll talk to you in the next discussion.